Hello everyone, welcome to this video. In this video, we will be discussing about Model Context Protocol, also widely known as MCP. It acts like a universal adapter for AI. We all know that LLM cannot perform anything without tools. Let's say you have a tool implementation that works for GPT. However, there is no guarantee that the same implementation will work for Gemini or DeepSeek. So MCP, what it does is that it standardizes the implementation. So whenever you use the MCP to do your tooling implementation, you can connect with any other LLM. Let's assume that I have three different tool implementation, maybe like this one for Google Drive, YouTube, and this is for something else. So right now, like in my organization, I'm using GPT. So I can connect with using the MCP with all the tools. So tomorrow I don't want to use GPT, rather like I wanted to use a Gemini. I don't have to make any changes. I just connect with the MCP, then start using all these tools. And day after tomorrow I wanted to use DeepSeek. Just as he says that, just remove these and like use these, connect with that. Let's start using the tool. So that way it's kind of a universal adapter. You can remove anything, add anything at any time without any effort required for the integration. If you are coming from a .NET or a Java background, you may be wondering like, why do I need another standard? Like I already have a open API standard. So let's see like what is the difference between the open API specification and the MCP. So open API, it's meant for a operation. Let's say like you want to add something or retrieve something. At the time you will be creating the individual operations, get, post, patch, delete, or whatever is that. For each operation you will be creating an endpoint. However, LLM are not for operation, rather it is task oriented. You want to complete a task, you have to create a task oriented implementation, not necessarily the operation. So basically the difference is that the task can have a number of operations. First you go and retrieve these and then like do this, do that, or whatever is that, right? So that is all a task, it is not the individual operations. So open API specification, it meant for operation, not for a task. While you can also do a task, I'm not saying like with OpenAPI specification you cannot do a task, but the main purpose of OpenAPI specification is to cover the individual operations. So having said that, there are quite a few problems that we have with OpenAPI specification, especially when you try to integrate with LLM. So if you see here this particular OpenAPI specification, so it is not greatly detailed enough for LLM to understand. So here it says that the verb, it's get verb, and this is the path, it takes ID. So LLM might not even know like what exactly this is, and like it look for the parameters, right? So it is not greatly detailed enough. However, like if you see the MCP equivalent, it has all this information, name aligns with the description, and like it clearly says that hey, like what exactly the input I'm looking for, what is needed, and all of those, right? And then likewise, like open API specification, it's meant for HTTP only, while LLM might use HTTP or any other mode of communicating, right? SSC, anything. So not necessarily the HTTP verb, HTTP protocol, but then like there are plenty of other ways to interact with the LLM, right? LLM and the client. Then we have a no guarantee for LLM tool safety. So basically like with this definition, so let's assume that you want to delete something. Before you delete something, you want to get the permission, right? So again, like it's a two different actions. Like first you need to get the approval, and then like you perform the action. So in MCP you can clearly see that hey, like whenever you have a safety profile, you have to first to complete that exercise before you actually do that. That can be done. And then like if you see here, OpenAPI specification will have lot of these individual operations. So that's what I mentioned, right? So it will have lots and lots of individual operations. However, like when you come to the the LLM, you don't need a lot of operation, you need to have a task. So that's what we will do it with the MCP. Pair one open API endpoint with the MCP implementation. So if you see here I'm saying like a get, this is the endpoint, and like it takes this particular parameter. So if you do the same thing in MCP, it will be something of this sort. So get the customer details. There is going to be a description that LLM can understand. It is going to have the required. This is what it is needed, and of type whatever is that, right? So the LLM can clearly understand the operation and what exactly it takes, what is the intent of this operation. So that's what the LLM needs to know. Now, with that understanding, let's go to the MCP and try to understand the components or primitives, right? So first we will have a tools or a verb. So whenever you want to perform an action, you will be defining a tool. Then you will have a prompt. So you can also attach the prompt as a part of a MCP, so that whoever is going to use your MCP, they can also use your prompt rather than they try to figure out the prompt. You can build in your prompt as a part of MCP and send it to them. Also, you can attach some resources that you think it's needed for your MCP to work properly. So for the first demo, I will be using this particular MCP implementation. So it's called MCP Server Calculator. So this is pretty simple implementation. The way you use it's a UVX and then like a name of the MCP server. And if you go to the code, it's pretty simple. So if you just go to the calculator.py, all they do is that they just defined one calculate method, and then like some implementation it's here, and they have a test and they have a toml file here. So we already discussed how do we package the Python. So you like they packaged everything and published. So this is what we will be using. Now let's go to the Visual Studio Code. So what I want to do is that I want to use the MCP server calculator that we discussed. It involves 3 different steps. First you have to import the tool, then you have to initialize the tool. So here, like if you see, like we are using the MCP Studio tool with the command UVX and the like a name of the MCP server, it's server MCP server calculator. Then when you define the agent, you need to just say that hey, like you need to use the MCP tool, but like you have to provide the MCP tool in the tools section. With that, let me go ahead and run the program. As you see here, like a user query, it's already provided here, so the program will not ask for a user input. So now let me go ahead and run the program. So this is going to be 24th. So there are few things that we need to understand. First, if you see here, first it is making a call to list tools request, list prompt request. What it will do is that it will go to the MCP server and ask for the list of tools available and ask for list of prompts available as a part of a MCP server. Now user query it's a provided. Now it is making the first call. It is doing the multiplication. Then it will be performing the addition. It says that I will use the calculator to perform the addition, and it is making a call. Then finally, like we have the result. So this is how the MCP server can be used. Now we will try to understand the type of tools, right? So I said like we are using the MCP Studio tool. Let's go back and try to understand the different type of tools. So if you see here, first we have a MCP Studio tool. So whenever you have a MCP installed, server installed and running in your local machine, you can use the MCP Studio tool. Basically, like it's a standard input output, right? So you will have everything in the same machine. So there is, the MCP client doesn't have to use a different protocol. You can directly use the input output to connect with your MCP server. And this is what typically we will be using for development purposes. Then we have a MCP streamable HTTP protocol. So let's assume that you wanted to consume the MCP, however, like it is hosted on a remote machine, then you have to use the streamable HTTP protocol to connect with that. Say like you wanted to make use of Google's MCP or Facebook's MCP, then most likely it is going to be the streamable HTTP protocol, right? Then the other one, it's the WebSocket protocol. So let's assume that so the difference between Studio streamable compared to the MCP WebSocket protocol is that WebSocket protocol, it's meant for a two-way communication or a bidirectional communication. So whenever you wanted to send the log or a high frequency of a data to your MCP, then you will be using the WebSocket protocol. And how do we use each of these? So if you just come over here, here we say like MCP Studio tool, provide a name and commands arguments, pass it, then you will use it, right? Then for the streamable HTTP, pretty same. Again, like a streamable HTTP protocol, name, URL. Instead of the commands, you will be passing the URL. Authorization, you will be providing all of these information here. Streamable, so it will be using the WSS protocol, so we will be passing that name and the WSS protocol that you will be passing it. Now we will also try to understand the architecture. So if you see here, the MCP client, in this case, like the program that runs our LLM, right? So that is going to be the client application. So think of this way: you have a front end application. It can be your web application or your IDE or anything that will make use of your application, the LLM application that you are building. The LLM application now consider as a MCP client application, not your web application or IDE, but the application that runs your LLM code. It's the MCP client. The MCP client will talk to the MCP server to get to know the tools information. Say like you want to perform some Google operation, Google Drive operation or a YouTube operation. So there is going to be a corresponding MCP server that your application, like your LLM application, need to interact with. So it will connect through either of these. It will either use the STDIO or a HTTP or a WebSocket protocol, right? Selection, again I said, like when you're really building a local development, you will be using the STD. But when you're like if MCP is hosted outside remote, then you will be using the streamable HTTP. For a high frequency connection, you will be using the WebSocket, right? So now with that understanding, let's go back and see like how do we implement our own MCP server. Let's go to the Visual Studio and try to understand that. Let me go ahead and create the console. So if you see here, not in this particular program, we are just using a single MCP server, but at times we wanted to use multiple MCP server. So if you see here, I'm using the exact MCP server calculator, and I'm also using the server time. So in this particular program, I will be showcasing how do we use multiple MCP servers. So everything going to be same except that we define two different MCP servers here, and in the tools section we provide both the names. That's it. Then the user will be asking, okay, what is the calculated value for this, and what is the time in Tokyo. Now if you see here, it involves two different tools. For this one we will be using the calculator tool, and for this we will be using the time tool. So now let me go and run this program. This is going to be 25th. Now let's go and run. So as you see here, first it used the calculator tool to perform this calculation, then it used the time tool to perform the time retrieval. This is how you can use multiple MCP servers. Now let's see how do we build our own MCP server. I am not going to create a package, rather it is going to be a simple implementation. And if you want to package it, I have a video that showcases how do we package the Python. But let me go and open this particular program. So first we have to create a MCP server, right? So in this case, I will be using the fast MCP. However, there are multiple frameworks are available. Let me go and show you. So if you're coming from Python, most likely we will be using the fast MCP. However, for TypeScript, you have a MCP SDK, and say like you have a open API implementation, then you can directly use Speakeasy that will convert your open API. Rather than rewriting everything, right? So you can very well use Speakeasy, and if you're coming from Go, you can use Foxy. So which one to choose, it really depends. So if you are starting with Python, you will be using Python fast MCP. But if you have a existing REST endpoint, then you can use Speakeasy. If you have a Go implementation or a high performance requirement, then most likely will be going with Foxy. Now let's go back. So if you look into this implementation, it is pretty simple. First you have to define this fast MCP, provide a name, and if there are any dependencies, you have to provide that dependency as well. Then you can define the tool using mcp.tool. Here if you see, I have defined a method called calculate mean that takes a list of float. and does the calculation. And I also have some prompt. So prompt you can define by using the decorator mcp dot prompt. You will provide the prompt here, so it is going to return that. Then you can run this. If you're running it from directly, then this particular method will get called. But what I want to do is that I want to use the mcp studio tool. So if you see here the name of this particular implement mcp server, it's a calculator, and the command it's python, and the this is what it is going to run. So that is just the name of my python program, and the it is going to use this argument as well. Now in this program we are trying to get the prompt as well as we are trying to use the tool. So if you see here, as we have defined the MCP server as a MCP dash server, we can use the get prompt method to get the prompt. And the name of the prompt, if you go back and see, this is the name of that definition, right? So all you need to do is that get prompt. You just need to provide the name of the definition, get the instruction. And if you see here, we are using that prompt for your agent. So again, the prompt by itself, it's defined in the MCP. We are getting the prompt using the get prompt by passing the name of that prompt, and using that prompt as a system instruction for our agent. Now again, the tool, as we discussed earlier, we will be passing the MCP server as a tool here. Now let me go and run the program. If you look into the query, it says that analyze the weekly server latency, whatever is that, some data set it's provided. So now let me clear the console. Now let me go and run this program. Let me go and run that. So let me expand this guy. So if you see here, it is running the MCP server using the stdio, and it is getting the tools and the prompt, and it is getting the prompt because I have used the prompt, right? And I am printing that prompt. So this is exactly the same thing, right? So this is exactly the same thing as we are getting the prompt. I'm also printing that. So this is exactly the same thing. This will be used for our system instruction. Now we are passing this user query, analyze the weekly server latency or whatever is that. Now if you just come over here, it is making a call, and it is calculating the mean. If you go to the program exactly, you will see the same logging information here. So calculating mean for data, whatever is that. So calculating mean for data, whatever is that, and the mean it's calculated. So now it will be using the prompt, as we are using the prompt as a system prompt, it will be using the same prompt, and it will be displaying the information. So like this, you can define your tools and prompts using the MCP. Now let me go and so this time around we have used stdio to run our MCP. Now we can also use a HTTP. So now let me go and open the HTTP. So if you just come over here, this is exactly the same program, except that I do not have the prompt, because we know that prompt is also going to work. That is not the main thing that I'm trying to showcase. I'm just trying to showcase the different protocols that can be used with MCP. So this time around we are not going to use the stdio, rather we will be using the HTTP, and the HTTP will be running in the port 8000. As you see here, this will be running in 8000. Now let me go down and open a new terminal, and let me try to run that. That is going to be 27. Now let me run it. So now the MCP server it's started, and it is using the port 8000. Now let me go to the terminal here again. Let me clear this. Now if I just come over here, this is going to be the same, right? If you see here, this time around I am using the MCP streamable HTTP, because I am using the HTTP based transport here, and name it's going to be the same calculator, and this time around I will be using the URL, and I don't have any headers because right now this particular implementation doesn't support any authentication. That's it. Rest of the things will be seen. So I will be asking, hey, what is the mean for this number? So now let me go and run this. So now as you see here, to find the mean of this particular number, I have used the calculator tool, and whatever is that. Now you see all this information here, right? Now if you just come over here, how do I know this uses my tool, right? So if you just come over here, you will see all the processing information. First, the client requested the server for a tool information, prompt information. Then you see that the calculating mean for data, whatever is that, because that is what we have here, right? So calculating mean for data. So it actually uses my MCP server to do the calculation, right? So this is how you can use MCP for your local development using STDIO transport, and like for remote deployment you can use a HTTP. So far in this video we discussed a lot about MCP, what is MCP, and how do we use the external MCP, and how do we build our own MCP, how do we deploy our MCP. All these things we discussed in this video. In the next video we will be discussing about the workflow, especially the executors. Thank you for watching this video.